Hi all. In this video module, we are going to learn about convolution theorem. In the previous module, we learned about convolution of two signals, f of t and g of t, convolved to give another signal. So this module is all about convolution theorem for Fourier transform. The convolution theorem for Fourier transform states that the Fourier transform of convolution of two functions is equal to the product of Fourier transform of individual functions. It's one way to state the convolution theorem for Fourier transform. Fourier transform of convolution of two signals is equal to the product of Fourier transforms of individual functions. So now we have the functions f was for f with the Fourier transform of f is capital F, and the Fourier transform of g, small g function is capital G. If so, what we can write about this theorem is the Fourier transform of the two functions, the convolution of the two functions is equal to f times g. What is f? Is the Fourier transform of first function f, and what is g? Is a Fourier transform of the second function. This can be stated in another way also. The inverse Fourier transform of product of Fourier transforms. These are the product of Fourier transforms. Take the inverse of that, or inverse Fourier transform of that. That will give you the convolution of original signal. That means the Fourier inverse of the product of Fourier transforms is equal to the convolution of the original signals. Okay, these are the two ways to say or express the convolution theorem for Fourier transform. Now, let us see the proof for convolution theorem for Fourier transform. We learned about for the convolution of two functions f convolve g equal to 1 over root 2 pi, where 1 over root 2 pi is a normalization function, integral within the limits minus infinity plus infinity gy f of x minus y dy. This is one form of representation of a convolution of two signals. Now, take the right side of these two functions. We know integral minus infinity to plus infinity gy f of x minus y dy equal to 1 over root of 2 pi integral minus infinity to plus infinity g of y. What is the term inside? Minus infinity to plus infinity e to the power minus I t x minus y dt. It's actually the inverse Fourier transform. If f of x minus y, Fourier transform of f of x minus y is f, then the inverse Fourier transform of f is f of x minus y. That is what they used there. So instead of this f of x minus y, it is written as inverse Fourier transform of f of t. What is f of t? F of t is the Fourier transform of this function small f of x minus y. F of x minus y യുടെ Fourier transform ആണ് ഈ f of capital T എന്ന് പറയുന്നത്. അതിന്റെ inverse Fourier transform ആണ് എഴുതിയിരിക്കുന്നത്. f of t e to the power minus I tx minus y dt. So that will give the same function itself. f small f എന്ന ഫംഗ്ഷന്റെ Fourier transform ആണ് f. അങ്ങനെയാണെങ്കിൽ f എന്ന ക്യാപിറ്റൽ f എന്ന ഫംഗ്ഷന്റെ ഇൻവേഴ്സ് Fourier transform ആയിരിക്കും സ്മോൾ f. So a small f ന് പകരം we wrote this term. That's all. Now, changing the this f of t, we are changing the limits and taking the const. We are interchanging the constant factors. So f of t taking out from the integral and taking the g of y into that, we can do this type of mathematical operation. I'm not going in detail into that one. Okay, so gy, so this become integral minus infinity to plus infinity gy e to the power. Now, what they're doing here is taking the exponential factors into e to the power minus itx minus minus. So it's become plus e to the power plus ity. So g of y e to the power ity dy. What is this actually? This term itself the Fourier transform of g of y. So you can write that as g of t. So now this become f of t, g of t, e to the power minus itx dt. What is this? F of t, g of t എന്നതിന്റെ product. F of t and g of t are the Fourier transforms of f and g, small f and small g. അതിന്റെ inverse Fourier transform equation ആണ് എഴുതിയിട്ടുള്ളത്. That gives what? The convolution of f and g. This is the statement that we made. നേരത്തെ പറഞ്ഞ statement ഇതാണ്. Inverse Fourier transform of product of Fourier transforms of two functions gives convolution of the original signals. Okay? This proves the convolution theorem. Now, for a special case when x equal to 0, we can write integral minus infinity to plus infinity f of t gt dt is equal to integral minus infinity plus infinity f of minus y g of y dy. It's only a special case of the theorem that we stated above. Okay. Next, we are going to learn about Percival's relation. The Percival relation says integral of Fourier transform of a function and the Fourier transform of conjugate of another function is equal to the integral of the products of the first function and conjugate of the second function. You can see here. Okay. So in order to prove this, we are using the help of a Dirac delta function. So let us start from the the right side of Percival relation, integral minus infinity to plus infinity, f of t, g star t dt, where g star t represents the complex conjugate of a function. Now, the function g star t can be written, or f of t can be written as inverse. If the f of t is a function with its Fourier transform f of omega, then what is the inverse Fourier transform of f of omega, that is f of t? So ft can be written as inverse Fourier transform of f of omega, and g star t can be written as inverse Fourier transform of capital G star x with respect to x, and here it is with respect to t omega. Now, slight rearrangement of these terms, we can write integral minus infinity plus infinity f t g star t is equal to, the right side become integral minus infinity plus infinity f omega integral, so this f omega is taken outside, integral minus infinity to plus infinity, and there is 1 by 2 pi root of 2 pi and 1 by root of 2 pi, of course, but we used another, actually this become like 1 by 2 pi integral minus infinity to plus infinity e to the power I omega actually ix minus omega t dx can be written as delta of x minus omega. That is why this term came here. This is called Dirac. This is a definition of Dirac delta function. You can see that in another section 12.21d in your reference book. Now, delta x minus omega gives a value 1 when x equal to omega. That is Dirac delta function. So x is replaced by omega. This becomes g star omega. So now you can write integral minus infinity to plus infinity f omega g star omega d omega. So hence the result. So we start from the integral minus infinity f of t d g star t dt. This gives the product of Fourier transform of those functions. So hence we derived the Percival's relation. Thank you, students. So in this module we learned about convolution theorem and Percival's relation. Thank you.